Let's take a look at how we can use our graphing calculator to find the maximum height of a football in this case, or some object thrown through the air. So in this example, we're given an equation that represents the path of that football. I can see that h stands for the height of the football, t seconds after it's thrown. So I've gone ahead and already typed in my equation. I've used x in place of t. I guess the first part of these questions is to find a viewing window that's going to help us see the parabola so we can find the max and min, or any other questions they ask us about this path. So right now I've typed it in, and I'm going to just graph in my standard window. So I've done zoom standard, or the normal -10 to +10 window, and you're going to see that that's a really terrible window to use because I can see the football go up, but then it's off my screen, I can see it come back down. So the first part of these problems is adjusting your window to see what's going to work. So let's press window. Some of this is a little bit of a guessing game, some of it's trial and error, and some of it's using common sense. So here's how I begin these problems. I always ask myself, well, what does the x, or the input value, stand for? Well, in this case, it's time, and so as a minimum time, I'm going to use 0. Typically, you're going to end up using 0 for your x min and y min. And then your x max is how long that football's in the air for. Well, if you imagine throwing something, it's not in the air super long. In fact, you saw that when we left it at 10, you saw the football come back down, the parabola drop back down. So I'm going to leave it 10, although you could probably shorten it up. Leave your scale number the same, that's just where your tick mark appears. Your y then, your output in this case, represents, remember, the height of the football. So the minimum height of the football could be 0. So again, I'm going to make the min 0. That's usually what we'll do in a story problem. And then the maximum height of the football, I don't really know. In fact, that's the question. So maybe I'm just going to guess at this number, something reasonable. Maybe I guess 100 feet. And now let's try graphing and seeing if that shows anything better. And so I see the football go up, I see it come back down, but look, I've just missed it. My graph is a little bit off. So I purposely did it wrong or bad because I wanted you guys to know that it's a guessing game. If you don't get it right the first time, it's okay, just try again. So I need my y max to go higher. I didn't quite see enough. My x max is plenty big. So let's go back to window, and let's make that y max a little bit bigger. It looks like I almost made it. In fact, it looks like if I look at my work from earlier, I know that that's 150, and that's going to work out just fine. So let's change it to 150, and like I said, it's kind of a trial and error until you find a window that works. So there we go. There's the football going up. There's the football going back down. Now I can use that graph to answer these other questions. So the first question is, find the height of the football 1.5 seconds after you throw it. Well, I could certainly do that simply by plugging in 1.5 for t, but here's a cool way you can do it using your graph. Hit the trace key, and if you move left and right, you can see that we changed the x value, the time. You can try to trace to 1.5, or what's really cool is now that you're in trace mode, just type in 1.5 and hit enter, and you'll jump right to the spot where 1.5 seconds, the height of that football, is 88 feet. We're looking for the y value, okay? So simple enough to answer that question. Next up, they ask about the maximum. That's typically what we'd be talking about currently in class. So to find the max or min of a parabola, we can again do that using our graphing calculator. So that's under the calculate menu. So hit second and trace, and you'll see max and min. This time we want to find a maximum. Sometimes you'll be finding a minimum if your parabola is facing the other way, if it's opening upwards. So select max, and what they're going to do is ask you 3 questions down here. They're going to say, move your cursor so you're somewhere to the left of that maximum value. Well, I know it's somewhere in there. You don't want to get too close to it, so I think that's fine. Hit enter. You'll see either a line or a triangle pop up on your calculator. Then their second question is go to the right bound. So move your cursor somewhere to the right of that high point. That should be fine. Hit enter. And then the third question is guess. You can get closer to it or just press enter. It's fine. And what it'll do is it'll find your highest point in there. Now sometimes you have to do a little bit of rounding because they give you weird values like this. I can see that they're trying to tell me that's 2.5. I don't know why they do 2.49. It's 2.5 is close enough for us. So let's see what they've asked us then, so we know which number, or maybe we need both, to pick. So first they ask us, what is the maximum height of the football? That, remember, is the output value, the y value. So the maximum height is 104 feet. They also ask you at what time does it reach its maximum height. Well, remember, time is our input, our x value, our t value in this example. So our time is going to be about 2.5 seconds if I round that off. So there we've used our graphing calculus. We found the max and min and just a generic question about the path of that football. I'd recommend when you finish this, always go back and just do zoom standard, zoom 6, to reset your window for your next problem.